Okay, so this is the paper 1 non-calculated paper that was sat in 2021. So it's the first new paper of the specification. Okay, so for question 1, work out the distance between these 2 points. If you know a formula, that's great, or you can think about it from a diagram. If we think about it on a diagram, so just draw a rough sketch. So minus 3, 7 is roughly over here. And 5, 1 is roughly about there. Okay, and we're looking at the distance between those 2 points. So if I think about the distance between the x coordinates, so I'm going from minus 3 up to 5, so I've got a distance of 8. And for my y coordinates, I've got from a y coordinate of 1 up to a y coordinate of 7, so I've got a distance of 6. So you can either think of it as a 3, 4, 5 triangle, if you know anything about Pythagoras, or you can use Pythagoras. So if we call this distance here d squared is 6 squared at 8 squared square rooted. Okay, but remember, for a 3, 4, 5 triangle is quite a good trick for a non-calculator paper. Pythagoras always works when the sides are 3, 4, and 5. So if you have multiples of that, this is a triangle that's obviously just been scaled up with a scale factor of 2. So D would actually be 2 lots of 5, which is 10. So nice, easy question to get us into the paper. Let's have a look at the next one. So work out an expression for the rate of change of y with respect to x. So we know the word rate of change means the differential. So we're going to differentiate y. So before I differentiate y, I'm going to expand the brackets. So that would give me 2x to the power of 5 minus 7x to the power of 4. I'm then going to differentiate to find the rate of change, because remember, rate of change is another word for gradient. And I'm going to bring the power to the front and take 1 off the power. Bring the power to the front and take 1 off the power. So that's my answer, 10x to the 4 minus 28x to the 3. Question 3. So I'm looking for the sketch that represents 3x plus 2y equals 5. I might want to rearrange this. Okay, so I want it in the form y equals mx plus c, so I'm going to move my 3x to the other side to make it negative 3x and divide by 2. So I'm looking for a sketch of a negative gradient and a positive y-intercept. Okay, so it's not going to be this one because it's got a negative y-intercept. Okay, this one has got a negative gradient and a positive y-intercept, so that's good. So just double check both the other ones, C and D, have got positive gradients. So it is therefore going to have to be B. Okay, domains and ranges of functions. So the function is given by 3x minus 5, and it gives us a range for the function. So the first thing you should do with any question with domains and range is draw the graph. So 3x minus 5, a bit like the last question, just a general sketch. So it's got a positive gradient and it's got a negative y-intercept. So that's going to be minus 5 down there. Okay, and then the range is from 13 to 19. So I don't want the whole graph. I just want 13 to 19. So let's imagine 13 is this point here. So remember, the range is the set of y values it can take. Let's say 19 is there. So actually, I don't want any of this part of the graph. I just want the part from the y values 13 to 19. So for my domain, I need to work out what the corresponding x values are as well. So if my y value is 13, I'm just going to solve this equation. So x would be 6. If I do the same thing for 19, okay, and now know that this is 6 and this is 8. So my domain is my set of x values the graph can take will be 6 to 8. Okay, so any domain and range question, always draw the graph and then you can work out what you need from the graph. For part B, the function g is given by x squared minus 4 with domain -1 to 3. So same idea, we're going to draw the graph, we're going to cut it off at the domain -1 up to 3, and then look at our corresponding range. So x squared minus 4, you can think about it in two ways. Either you can factorise it, so difference of two squares will be x plus 2, x minus 2. So I know it is this shape here. Okay, or you could have thought about it as transformation. So you think about the x squared graph, goes through the origin, is going down 4. So that minimum point will be at -4. Okay, so if we only want that between -1 and 3, so I'm going to chop it off here at 3 and -1. So I don't want any of this part of the graph. So I'm stopping it at -1. Okay, so think about the range. The smallest value will still be this minimum point here at 4. My maximum point is going to go right up to the end here, isn't it? So if I substitute in x equals 3, I will do g of 3 is 3 squared minus 4, which is 5. Then the graph can only go up as high as 5. So my range is -4 up to 5. And part C wants us to work out the inverse function. So remember, with the inverse function, we swap the x and the y around and then rearrange to make y the subject. So if I rearrange this, that means my inverse function, h minus 1x, is 2x minus 3. So easy peasy, an exact overlap with a question that you could get in GCSE maths as well. Number 5, the term of a sequence is 2n plus 47 over n plus 1. A term of the sequence has got a value of 5. So we know when we sub in the position, we get an answer of 5. So working backwards, we want to find what n is. So you're just solving this equation. Okay, so n equals 14. Write down the limiting value of the sequence as n tends to infinity. So what is happening to these terms as n gets really, really, really big? Okay, so the best way to think about it is 2n plus 47 over n plus 1 is quite tricky to think about. It's probably quite a tricky graph to draw. Okay, so actually what you could do for this question, if you divide them, so n plus 1 is going into 2n plus 47. So this is quite a good little trick for being able to draw a graph that's quite tricky to draw without a calculator. So n goes into 2n twice, and then I subtract and get a remainder of 45. So we can write 2n plus 47 over n plus 1 as 2 whole ones, add 45, because that was my remainder out of n plus 1. Okay, so that's a lot easier to draw. So we should know what a reciprocal graph looks like. So 45 of n plus 1 would have, obviously think about 2 plus 45 over x plus 1. Okay, so it would have an x asymptote at minus 1. Okay, and then the 2, think about graph transformations, this 2 would move it upwards. So where your asymptote would normally be the x-axis, the plus 2 moves it up. So it's here. Okay, so obviously as n tends to infinity, we're thinking about as n gets bigger and bigger and bigger, we can see that graph gets closer to the asymptote. So your limiting value would actually be the horizontal asymptote, which is 2. Okay, there is an easier way of doing that. If you have got a fraction where the coefficient of x, the power of x on the top is the same as the power of x on the bottom. Obviously, whenever you divide them, do that long division, you're going to look at this coefficient here. This is obviously a 1. So you're going to end up dividing those. That number at the front is always going to be the coefficient of x on the top divided by the coefficient of x on the bottom. Okay, so actually you could just divide those. That will always be your horizontal asymptote. Okay, if you are good at limits, okay, you can think about limits. So think about infinity. If you're doing 2 times infinity plus 47, and then 1 times infinity plus 1, the 47 and the 1 are so irrelevant when you're thinking in terms of infinity. So actually what we're saying is you're doing 2 times infinity divided by infinity, which is 2. Okay, so if you're any good at limits, depends how you've been taught to do this type of question. Okay, but if you think about asymptotes, obviously on a calculator paper where you've got a graph, you can sketch a graph. It's definitely a lot easier. Right, number 6. So we've got a sketch of sine x from 0 to 360. We're told that sine 220 is equal to minus k. So I'm just going to put roughly where that would be. So we're saying that is minus k. Work out the two values of x for which y equals k. So in other words, I want this and this. Okay. So we are just thinking about symmetry of the graph. If this is 220 degrees, then I'm looking at this part here. So this from 180 to 220 would be 40. So that's going to be the same everywhere. So it's going to be the same here. And it's going to be the same here. So this is 40. And this is 40. Okay. So therefore, my other values are going to be 40. And if the gap's 40, 40 before 180 would be 140. Okay, quadratic inequalities. I'm going to expand the brackets. Okay, and actually the quadratic part cancels out. So if I move it all over to one side, 2x squared take away 2x squared disappears. So what, minus x minus 7. Not really feeling the negatives, so I'm going to make my life easier and move those both up to the other side. And then that leaves me with x is bigger than minus 7. Okay, so that could be a question that you had at GCSE that it's no different. There's another question you could have at GCSE, no difference. So think about surds and multiply out surds. So you can either multiply them out and then simplify them, but it's probably a lot easier if you simplify them first and then multiply out. So I'm going to leave my brackets in for the minute. So root 75 is the same as root 25 times root 3. Okay, and root 48, think about the factors of 48, is the same as root 16 times root 3. So I've got 5 root 3, add 4 root 3, which ends up being 9 root 3. So if I then multiply 9 root 3 by root 3, root 3 times root 3, remember, is 3, so I get 27. So after all that, it's simplified down to 27. Question 9, again, could be on a GCSE paper. So 3 brackets, multiply 2 of them, so I'm going to multiply the first 2. And I'm going to simplify the middle terms. Okay, and then when you've got that answer, I need to multiply by the third bracket, which is x plus 2. So we're going to multiply all of them by x to start with. And then I'm going to multiply all of them by 2. And then collecting terms together, got 6x cubed. And I've got 12 minus 23. My brain's not working today. 11. And 20x minus 46x. That's 40. So no different to a GCSE question. Nth term of a quadratic sequence. Again, no different. Okay, so work out the first difference. And then work out the second difference. So the second difference, if we halve it, gives us the coefficient of n squared. So I know I'm going to have minus 1n squared. Okay, so I'm going to make a little table. So I'll start with 0. Store the 0 in the term. First term, second term, third term, fourth term. My term un is 0, 1, 0, and minus 3. So if I work out what my minus 1 times n squared is, so 1 minus 4, sorry, minus 9, minus 16. What you want to see is how much more you need to get to the term. So if I'm at minus 1, then I've got to add 1. So you're doing un minus n squared. Okay, so 0. So I've got minus 1. I need to add 1. And then we've got minus 4. I need to add 5. At minus 9, I need to add 9. And at minus 16, I need to add 19. Something's going on there, isn't it? Not 1, not 3. Then minus 2's minus 1 squared. Oh, minus 1, 1 minus 4, no, minus 9, minus 3, minus 16. Got that wrong, didn't I? It's 13. It's better. Okay, and then when you've done that, so this is what we've got left to add on. So you just want to make this a sequence in itself. So it's adding 4 each time. So thinking just about linear sequences, because my difference is 4, that's going to give me 4n. Go back to the previous term. So 1 take away 4 is minus 3. Okay, so your sequence is minus n squared plus 4n minus 3. Again, no difference to GCSE. Matrices, obviously something that isn't in GCSE. So we're given this expression where two matrices multiplied together to get K multiplied by the identity matrix. We've got to work out A and B. So I'm going to start by multiplying my matrices together. Okay, so remember for this element here, for the first column and the first row. So you're going to go along the first row and down the first column. So go 2 times A and then add 1 times 0, which is obviously 0. For the next position here, I'm going on the first row and the second column. This time I'm going down this column. So I'm going 2 times B and then add 1 times 0.4, so 0.4. Okay, for my next one, I'm now on the second row, so I'm going along the second row and the first column. So 0 times A is 0 and 3 times 0 is 0, so actually I've just got 0. And then for this position here, I'm on my my second row and my second column. So I'm going to do 0 times B, which is 0, and then 3 times 1.4, so 1.2. Okay, so I know when I multiply those out, I'm going to get the identity matrix. So 2a, 2b plus 0.4, 0 and 1.2 gives me, with a k at the front actually, k, and the identity matrix, remember, has got 1s in its leading diagonal. So if I multiply that by k, it's the same as doing k 0, 0, k. So if I compare these two matrices, okay, I've got my 0 here and my 0 here. Okay, and I've also got a k here and a 1.2 here. So I know k must be 1.2. I can then work out a and b from that. So k is also the same as 2a. So 1.2 is the same as 2a. So a is 0.6. And then obviously if I look at the b, I know this term has to be 0. So 2b plus 0.4 has to equal 0. So 2b is minus 0.4, b is minus 0.2. Okay, so really that was just a question on multiplying matrices, but obviously you had to know what the identity matrix was. So look at number 12. So we've got a circle, we've got the centre 4 minus 2. We know it passes through the origin and 8, 0 on the x-axis. We've also got a tangent. So equation of the circle, we need to know the centre point and we need to know the radius. So we've got the centre point. So what we need is a radius. So if I join this point C to this point A, think about what we did at the very beginning of question 1. We just need to find that distance there. So I'm going to look at the difference in my x-coordinates. I'm going from 4 to 8, so this side is 4. In my y-coordinates, I'm going from minus 2 up to 0. So the length of this is 2. So therefore, your radius is 2 squared, add 4 squared. Okay, and then square root that. So r is root 20, which is root 4 and root 5. So 2 root 5. I don't actually need that, but I think we'll probably need it later in the question. Okay. So remember, it's x minus the x coordinate of the centre. So 4 squared y minus 2 squared equals r squared, which is 20. For part B, we want the equation of the tangent to the circle at A. So this part could be a GCSE question. So we need the gradient. Okay, and we don't have the gradient, but we do, or we can work out the gradient of the radius. So we've just made that little triangle. It's 4 across and 2 up. So if I work out my radius gradient, okay, I'm going to do my 2 up divided by my 4 along. So that gradient is a half. I know my radius and my tangent are perpendicular. So therefore, my tangent must have a gradient of -2. I also know that it goes through 8, 0. So I'm going to use y minus y1 equals mx minus x1. My y coordinate was 0. My m was -2. And my x coordinate was 8. So my equation of the tangent is -2x plus 16. Okay, so this question is an exponential graph and gives us a point on the curve. We've got to try and find out what k is. So I can sub that point that I've got in. So my y coordinate is 3 and 16th, an awkward number. And that is equal to k to the power of 2. Okay, so not that, what I'm trying to work out. I'm trying to work out the value of k. So actually that is quite helpful. So if I'm trying to work out the value of k, I can obviously just square root it. So you're square rooting 3 and 1/16. So I change it to a mixed fraction. To a mixed fraction? Oh, it is. I'm going to change it to a top heavy fraction. So 16 times 3 is 48. So it'll be 49 over 16. So if I square root that, square at the top, square at the bottom, will give me 7 over 4. Okay, point B on the curve has got x coordinate -1, and we want to work out the y coordinate of B. So this is -1. I'm trying to find this one here. Okay, so we can just sub it in. We've just worked out what k is. So we know the equation is y equals 7 over 4 to the power of x. So if my y coordinate is -1, I'm doing 7 over 4 to the power of -1. And I know that is going to give me the reciprocal. So it's going to be 4 over 7. Three simultaneous equations. Okay, so I'm going to have a close look at this one. So if we look, let's label them 1, 2, and 3. Equation 3 already has no b in it. Okay, so what I'm going to do is I'm going to eliminate b from equation 1 and 2. So I'm going to double equation 1 to give me 8a minus 2b plus 6c equals 54. So equation 2, I'm just going to leave as it is. 3a plus 2b minus c equals 5. I'm now going to add those two together because then I can eliminate my b terms. So 11a plus 5c equals 59. Okay, I'm going to call this equation 4 because essentially it's a new equation. Okay, equation 3, remember, already didn't have a b in it, so it was just this. Okay, so now I've got two simultaneous equations and I can obviously work out A and work out C. So I'm going to add them together to give me 13A equals 52. So therefore A equals 4. You're going to sub that back in. So 11 times 4 plus 5C is 59. So 44 plus 5C is 59. 5C is 59, take away 44, so 15. So C is 3. Okay, and now you've worked out those two, you can throw it back into any of the others, it doesn't matter, I'm just going to go for the top one. So equation 1 was 4A, and we know that A is 4, so that must be 16, minus B plus 3C, so C is 3, so that will give me 9, and that should equal 27. So we've got 16 add 9 is 25, minus B is 27. So that leaves me with B as minus 2. Okay, so think about the game with this. The tactic is eliminate one of your variables. Doesn't matter, it could have been A, B, or C. I picked B because it was the easiest because it was already gone from one of them. But it wouldn't matter if you eliminate any of them. So use two of your equations to eliminate one element, then use another two equations to eliminate the same element. So then you'll just end up with simple simultaneous equations like this with two unknowns. Right, number 15. Work out the value of x, where x is between 0 and 90 for 3 tan squared equals 1. So if we rearrange that to get tan squared the subject, it would be a third. I'm then going to square root. So when I square root 1, I get 1. When I square root 3, I get root 3. Okay, but you obviously, when you square root, get a plus or a minus. Okay, so we're only interested in the values between 0 and 90. Okay, so if you think about cast diagram, we're actually only interested in the one in this quadrant here. Okay, so I'm not really interested in the negative 1 over root 3. So I just want what my principal angle is for 1 over root 3. If you're not good at knowing these values, so you need to learn them as a table. There is a hand trick if you Google hand trick on YouTube. I think that's quite tricky sometimes because it's easy to forget which fingers you have to divide by which fingers. Okay, so I think the easiest thing is to draw the triangle. So if you draw an equilateral triangle, okay, so this side is 2, which means that side is 2, which means this side down here is 2, but I'm going to cut it in half. So actually it's 1 and 1. Okay, because it's an equilateral triangle, it has got an angle of 60. Down here, up here would be 30 because I cut it in half. Okay, if I just think about this right angle triangle, so I'm just thinking about half of it. If I work out the other side using Pythagoras, so 2 squared, take away 1 squared square rooted, I'll get root 3. Okay, so I'm looking for, if I look at this angle up here of 30, tan is the opposite, which is 1, over the adjacent, which is root 3. So that means my angle is going to be 30. Okay, and none of the other angles matter because of the small domain of 0 to 90, which made that question a lot easier. Okay, let's have a look at number 16. So we're trying to show that 2x plus 1 is a factor of f of x. Okay, if that is true, and I subbed in x minus half, because x minus half must be one of the roots. So if I do f of minus a half, a very nice number, 200 minus a half cubed, so just cube the top, cube the bottom, minus 1/8, plus 100. So same as before, square the top, square the bottom, so 1/4, minus 18, minus half, minus 9. So not very nice numbers at all. Okay, so you've got 200, negative 200 divided by 8, plus 100 divided by 4. So they're obviously equivalent fractions, aren't they? So we could double this one, it would be the same. So because one's negative, one's positive, they will cancel out. Then you've got minus 18 times minus a half would be plus 9, minus 9. So we do, in fact, get 0. Okay, and it's really important. Once you've said it's 0, you do need to write words. So you do need to say, therefore, 2x plus 1 is a factor of f of x. Okay, so hence solve fx equals 0. So we have got one factor, but we need more. So if we do long division, so 2x plus 1 into 200x cubed plus 100x squared minus 18x minus 9. So 2x into 200x goes 100x squared. Then going to multiply 100x squared by 2x plus 1. And actually get 0. So bring down the next term. So 2x into minus 18x goes minus 9 times. So minus 9 times 2x is minus 18x, minus 9, 0. So therefore fx is my 2x plus 1 multiplied by 100x squared minus 9. Now I can factorise that. And you should recognise it as the difference of two squares. So 10x plus 3 and 10x minus 3. Okay, so now it's factorised, you can solve it. So this was x is minus a half. This one is x is minus 3 over 10. And this is x is plus 3 over 10. So they are your three solutions. Okay, so this is exactly like what you could see from a GCSE question. So here is the graph of x squared minus 6x plus 5 from 0 to 6. So what we want to do is, if we look at this equation it wants us to solve, we don't really want to solve that because we haven't got the graph of x squared minus 7x plus 9. So what we want to do is use the graph of x squared minus 6x plus 5. Okay? So if I add an x to both sides of this equation here, I then get x squared minus 6x plus 9 equals, then add x to the other side as well. So it's now looking closer to the graph that I've got. Okay, but I don't want to have a plus 9 on the end. So you might want to take 4 off of it as well. And now I've got the equation that I want. So we need to draw the line x minus 4 on this graph and read off. Okay, so just pick some points it doesn't really matter what they are. Okay, so I'm going to go for when x is 0, y is -4. When x is 4, y is 0. When x is 6, y is 2. And if you plot those points, okay, you can then read off at the points you want approximate solutions. So my line is not very straight. Obviously, you're going to do this with a ruler. So you can probably read off a lot better than I can. This line particularly went wonky. Read that one there. Yeah, I reckon that's fair. So you've got 1.8. They do give you a bit of flexibility on this for drawing the graphs. And 5.4. Okay, that's exactly the same as what you would have at GCSE. So using the cosine rule, let's have a look at what they want us to do here. Okay, so if you're not good at rearranging the cosine rule, thinking about it in different letters, some people like to just call it A, B, and C. Okay, they're not going to moan that you've relabeled their triangle. So we've got 7 squared. Remember, it's A squared, and you get given this now this year, B squared plus C squared minus 2BC cos A. So we've got 7 squared equals x squared plus 3 squared minus 2x times 3 times cos 60. So another situation where you need to know that triangle. Go back up to here. So cos 60. So 60 is here. Cos is the adjacent. So 1 over the hypotenuse 2. So it's a half. So we've got 49 x squared plus 9 minus 6x multiplied by half. So what's happened here is they've just given you a quadratic. So we've got x squared minus 3x. I'm going to move the 49 to the other side to give you minus 40. So we want to factorise that. So remember, you want two numbers that multiply to get negative 40 and add to get negative 3. So I want to have plus 5 and negative 8. So x equals 5 minus 5, or x equals 8. Because we're talking about lengths here, so it does say work out the value of x. It doesn't want both values, it just wants 8, because obviously you cannot have a negative length. Okay, so we've got fx is a cubic function. And it's talking about where it's increasing, decreasing, and increasing for. So draw a possible sketch from 2 minus 2 to 6. So remember the general shape of a cubic function is like that. Or obviously if it's negative, it could be like that. So we know it's increasing for less than -1, and then it changes to decreasing from -1 to 2. So that means your maximum or your minimum, no, increasing, decreasing. So your maximum point, because it's increasing and then decreasing, will be at -1. Okay, so somewhere on this line is going to be your maximum point. Okay, I'm going to draw and then probably rub out. So I'm just going to put it here for the minute. So it's increasing and then it's decreasing up until the point 2. And then at the point 2, it starts to increase again. So it's going to have that shape, okay? All the way up to 6. Probably should go. Okay, and then so we've dealt with this section here. We then need to think about this part here. So y is less than 0 for x is less than 5. So when x is less than 5, we want to have our y values all below. So we need to shift this so it's beneath. So in other words, that's where your root is, isn't it? So your root, and these are your maximums. And then it's bigger when it gets to 5. So it's actually the only root it has is at 5. So it can't cross. So you see mine crosses in 3 places. So I've got to shift it down so that maximum falls beneath the axis. So it's going to be more like here. And then it goes through 5. So I'm literally just going to translate that graph. There we go. Okay, so now both things are true. I've got my maximum at 1, I've got my minimum at 2, and then I've got the graph above the x-axis when it's bigger than 5, but below for less than 5. So that definitely took a little bit of thinking. Right, Miriam's birthday is 14th of 9th, 2006. She makes a 4-digit number code using digits from her date of birth. The 4-digit number she makes must not start with a 0. It has to have all different digits. How many codes can she make? So it can't start with a 0. So it has to start with 1, 4, 9, 2, or 6. Okay, so we're picking, so we've got 1, 2, 3, 4, 5 options. For her second digit, okay, the 0 can now be included. Okay, but whatever she picks, they've got to have all different digits. So whatever she picked for the first digit can't be picked again. So let's assume that she picked 6, for example. You can't pick 6, but we've still got 1, 4, 9, and 2. And now you've got the 0 thrown in as well. So you've still got 5 options for the second digit. For the third digit, okay, we've now used up 2 of them. So we've used the one that we had in the first digit, the one that we had in the second digit. So we've now only got 4 options left. And then for the fourth digit, again, you can't repeat. So we've now only got 3 options because we used that one in the last one. So it'll be 5 times 5 times 4 times 3. So 5 times 5 is 25, times 4 is 100, so 300. Okay, so it's very much about logical thinking. ABC is a triangle, perpendicular meets BC at D. And it gives you what BC is, gives you the area of the triangle, and we're trying to work out the length of AD. Okay, so I'm just going to put this information on the diagram. So the whole of this here is 6 plus 2 root 7. Okay, the height is the thing that we're trying to work out. And it gives you the area. So if you think about the area of a triangle, area is half the height times the base. So we know the area is 13 plus 3 root 7. And we're doing half times the height times the base, which is 6 plus 2 root 7. So I'm going to halve this now. So h times 3 plus 1 root 7. Okay, so to get h, you obviously get to divide. So 13 plus 3 root 7 over 3 plus 1 root 7. So when you're dividing, you are going to rationalize the denominator. So multiply by 3 minus root 7 on the top and the bottom. So if we multiply those out, we've got 39 minus 3 times 7 is 21, plus 9 root 7 minus 13 root 7. And then on the bottom, we've got 9 plus 3 root 7, and the minus 3 root 7 will cancel out. Then we've just got root 7 times root 7, which is 7. So if we do 39 take away 21, we've got 18. And then 9 minus 13 root 7 is minus 4 root 7. Divided by 2. So 9 minus 2 root 7. Okay, you've got an equation with indices here to solve. So let's have a look what's going on here. So we've got, whenever you've got anything with powers in, the best thing to do, where's the best thing to do? It's not a very nice question, I'll give you that. So I'm going to make this 2 to the 3x, because 2 to the 3 is the same as 8. Make this 2 to the 56. We'll make this 2 to the 2 to the 26 over 30. So what have we got? 2 to the 56 minus 2 to the 52 divided by 30. Okay, so what I'm going to do is factorise out 2 to the 52. So that'll leave me with 2 to the 4 to make 2 to the 56, take away 1. Okay, now 2 to the 4 is actually 16. Take away 1 gives me 15. So I'm then multiplying it by 15 over 30, which is a half. So it's the same as dividing by 2. So that then becomes 2 to the 51. So if I compare my powers, 3x has got to equal 51. If I divide 51 by 3, I get 17. So questions like that are all about working with powers of the same base. And last question for this paper. So if h, j, and k are points in the circle, chords h, j, and kf intersect L, EFG, the tangent FH and JK at parallels. Just make sure you're aware of all the information in the question. Most of it is on that diagram. So angle FHJ is 2x. Give reasons why FKJ and HJK, so this one and this one are also equal to 2x. Okay, so FKJ should be relatively straightforward. Okay, so this is 2x because of the circle theorem, angles in the same segment. Okay, so that would be why that one's 2x. The next one, HJK. So why is this one 2x as well? So if we have a think about it, we've got angles. So try and work out with these sorts of questions anything you can work out, basically. Okay, so we have got parallel lines here. So remember, it's not just about the circle theorems. We've got a parallel line here. We've got a parallel line here. Okay, so because you've got parallel lines and that's 2x, you've obviously got alternate angles. You've got that Z shape here. Okay, so that is because of alternate angles and parallel lines. Okay, work out the values of x and y. So what links x and y? Let's have a think about this. So we've got angles in a triangle. So if we look at this triangle here, we've got 2x, a 2x, and a 7y. So 2x, add 2x, add 7y is 180. So 4x, add 7y is 180. Okay, and then if we look at the rest of the information that we've got, so any other angles you can work them out. So you've got opposite angles here, so this would also be 7y. So we've also got, we've got 98 down here. We've got 2x, we have got 3y. So if we think about the alternate segment theorem, 3y is the angle between the chord and the tangent. Okay, so the angle that chord subtends is actually here. So that would have to be 3y as well. Okay, so if we think about this big triangle here, we've got 98, 3y, and 2x. And we know that's going to equal 180. So 2x and 3y, if we take away 98, so it'd be 82. So you've now got simultaneous equations that you can solve for x and y. So I'm going to double this equation too. To make 4x add 6y is 164. And then I'm going to take away equation 1. So 4x take away 4x, 6y take away 7y is minus y. 164 take away 180 is minus 16. So therefore y is 16. And if we sub back into either equation, we'll go for 2x plus 3 lots of 16 is equal to 82. So 2x is 82, take away 48. So 50, 34 divided by 2 is 17. So y is 16, x is 17. Okay, that's the end of that paper.